we get to our last section of, or last part of section 1.5. I'll just put the name of this. I almost hate writing this name because some of you guys are going to look at this and say, oh, well, with this name, I'll never be able to do it. All right? But this word doesn't really mean what you think it means. All right? They're called complex. I was going to put numbers, but it's not. Complex fractions. Now, when you think complex, what's the first thing that pops in your head? Hard. Yeah, it's really hard. Okay, I'll never be able to do it. All right, that's not what this word's talking about. It doesn't mean that, oh, these are the real hard fractions. It's not what it means. All right, it's like an English class. Remember having like simple sentence, compound sentence, complex sentences? Remember that stuff? It's kind of the same thing. If I remember right, I say this every year, and I should talk to an English teacher about this, but who's good in English? Anybody in here really good in English? Okay, what's a complex sentence? Isn't it like a combination of, what is it, like a simple and a compound or something like that? Or two compounds, or, I don't know. Is that what it is? Which one is it? Do you remember? So it's like a mixture of any of those, like a simple compound or two compounds or something like that, yeah. And that's what this is basically. It's basically like a combination of a fraction inside of a fraction, all right? It's like two simple fractions put together, all right, as one big old fraction, all right? For instance, let's do this. Let's say, I'll just make it really simple. A plus B over C over, let's say, let me see if they write it. I'm just making this up here. No, they don't write it like this, but that's okay. A plus B over C and D plus E over F or something, okay? That right there is a complex fraction. Why is that a complex fraction? It's not a complex fraction because it looks real hard. It's a complex fraction because look what we have. We have a fraction, and that's part of one big fraction, isn't it? Do you see that? This fraction right here is actually the numerator. This fraction right here is actually the denominator. But look within that numerator. That numerator has a numerator and a denominator, doesn't it? All right, so it's kind of like two fractions that make up one big fraction. That's why they call it complex fractions. All right, so that's basically what a complex fraction is. So let's actually do a problem. We'll start off right with an example because they really don't even they don't really give you any explanation about this compound fraction stuff. They just start right off with an example. 1 plus 5 over k. All right, so look at this. This is a complex fraction, isn't it? Because look, you got this fraction on the top, you got the fraction on the bottom, and you got this big old fraction bar in between. Everybody see that? So what in the world are we going to do with this? Well, let's do it one at a time. Let's just take the numerator and figure out what the answer is to that. Simplify that fraction on the top. Then we're going to take the denominator and we're going to simplify that fraction. Okay? Let's write down. If you're not writing down, I see eyes closing. Okay, and that's why your eyes are closing because you're not writing any of this stuff down. So should have a pen. Everybody should have a pencil in their hand. Okay, and then writing on their paper. So look what we're going to do here. What we're going to do is we're going to take this and we're just going to simplify it. So we're just going to add these fractions together, or in this case, we're going to what? Subtract the fractions. So let's write it so we can subtract them. Instead of 6, how do you think I can write it? 6 over what? 1 minus 5 over k. That's the first thing we'll do, all right, just to make it look a little bit more like a couple fractions. Let's do the same thing to the bottom. Let's put 1 over 1 minus 5 over k. Now, does the 5 over k and the 5 over k cancel out with each other? Kind of looks like they might. Do they? Why not? Yeah, because it's being part of a subtraction problem, right? We covered that. Yes, plus. We covered that before, right? Whether it's addition or subtraction, you cannot cancel those two things out because this is being subtracted from something, this is being added to something. They don't just divide out because division and addition are not inverse operations of each other, okay? So now let's take this and let's simplify it. So what I'm going to do is I just want to subtract these fractions. So what do I need to do to subtract fractions? I need to find a what? Common denominator. Now this is an easy common denominator. What is it? I got a 1 and a k. It's just k. So now, what did I do to 1 to get to k? I multiplied it by k. So I multiplied the top by k. I'm going to go kind of quick because we've talked about this quite a bit. What did I do to k to get to k? Well, nothing. Technically, I multiplied by 1, but I don't have to change it at all, so I don't change the top. So I just put a minus 5. Everybody see that? write it down. You're going to have to, I'm sorry, but you're going to have to, because I'm just running a little short on time, you're going to have to write it down and go back and see what I just said. Look at the bottom here. I got 1 times k, which is k. What did I do to 1 to get to k? What did I multiply it by? I multiplied it by k. So I do the same thing to the top. Multiply the top by k. So I get a k. Plus, what did I do to k to get to k? Nothing. Didn't do anything to it. Multiplied it by 1, basically. So I just do the same thing to the top. I don't change it at all. So it's just plus 5. So there you go. So I took both fractions, the one on the top and the one on the bottom, and I simplified both of those fractions. Now let's go back in time for a little bit. All right, do you remember when you were a little kid? Just a different color. And you learned this kind of stuff. You went 3/2 divided by, let's say, let's not do that. Let's say like 5/8. Do you remember doing that? Division? Yeah, what'd you do? Say it. You flip it. That's right. Remember that? You really never did division with fractions, did you? You never really did. What you always did was this, though. You took division and you turned it into multiplication. And then what'd you do to this thing, though? You flipped it and you went 8/5. Does that make sense? That's what you did for division. Who remembers that? Okay, good. What is this big old fraction bar right here? It's a fraction, but it's acting as a divide, isn't it? It's division, isn't it? All right, so what we're going to do, right here, we kept the first one the same, didn't we? And we flipped the second one. So which is the first one here? The top, the numerator. So I'm going to keep that the same. But instead of dividing, we don't divide. What do we do with fractions? We multiply by the, what's the fancy math word? Reciprocal, right? We multiply by the reciprocal. So what am I going to do to my denominator now? Flip it. That's right. Flip it. So k goes on top and what? K plus 5 goes on the bottom. Very good. Everybody see that? Now let's go back here. Once we did that, once we multiplied by the reciprocal, what did we try to do? You didn't just multiply straight across, did you? All right, what'd you do? 2 goes into 2 once, 2 goes into 8, what? 4 times, and then you can multiply, right? So what do you think we're going to do here? Same thing. That's right. So k divides into k, doesn't it? We've done that before. See how it all builds up, right? We learned little pieces, back before, and now it all comes together, doesn't it? So that goes. What about this? Can I cancel out the 5s here? No, because remember we just talked about that earlier. That 5 is being subtracted, this 5 is being added. You can't cancel out the 5s. You can't cancel out the 6 or the k's. People say, well, but that k is being multiplied by the 6. But look at that whole term, though. What's happening to that whole term? Something's being subtracted from it. So you can't cancel anything out. So how do we write this answer then? 6k minus 5 over k plus 5. And that's it. That's all you can do. So really, is the complex fraction that complex? Is it that difficult? Is it that hard? I don't think it is. I think it's just going back in time and doing this, right? You know how to find a common denominator right there and right there. So you had to find a common denominator, simplify the two fractions. And then the second part, that's the easiest part, I think, is changing a division problem into a multiplication problem. And that's what we've done right there. Think you can handle something like that?
Yeah.
All right, good. You know it's not going to stay that easy, right?
Yep.
You're just waiting, aren't you? Yeah, so, I don't know, let's go with this tan. Have I ever used this tan color? Have I? Okay. Can you read that all right? Okay. Now look at this. Now we're getting in, that's just the numerator right there, all that mess. Yeah.
Wunderbar.
Yep. Hope you're writing this stuff down. Norval, you getting all this down? Or you got a blank piece of paper in front of you? So, what are we going to do here? We're not going to do that division yet. We're going to wait to the very, very end, okay, to do that division. All right, so what do we have to do? Simplify the fractions, right? So simplify the top. So what I have to do is I have to find a common denominator with the top. So keep that big old fraction bar. So I'm going to write another fraction bar for this thing right here. Now watch. If you wanted to make it a little easier for yourself, put that in parentheses, because you're kind of used to seeing that in parentheses, aren't you? So we could do that if we want. Now look at it. I've got two things. I've got an a plus 1. Remember, this acts as one thing. Don't think of it as, oh, I have 1a here and 1a here. No, this is being added to something else. So you have to look at that as one whole group. Make sense? All right, so that's a little tricky. That's where people could go wrong a little bit here. So what do? I've got 1a plus 1, and I have 1a by itself. So what do I do to those two things? Just do what to them? Just multiply them together, right? Just like if it was a 3 and a 5 or something, right? I would just multiply the two things together, and there it is. That's my denominator. Let's do the same thing with this other one. Same exact thing, isn't it? I've got a times a plus 1. Good. That's my denominator. Now, what do we ask ourselves? We ask ourselves, how did we get from this to this denominator? What did I have to multiply this by to get to that? Yeah, I just had to multiply by a. It's that simple. So I multiplied this by a, don't I? All right, and it's going to be a squared. Let's just write that down. So it's going to be a squared. What did I do to this a to get to this whole denominator? It's already got an a. What doesn't it have? An a plus 1. So what do I do with this? Multiply it by a plus 1. And that's easy multiplication because I'm just multiplying it by a 1, right? Everybody with me? All right, good. So let's figure out what that is. So that's going to be plus what? Just a plus 1. Good. Now I can't simplify anything with this, can I? So I just leave it like this. Let's do the same thing to this denominator right here. So what did I multiply by a by to get to this? A plus 1. It's kind of the same process. What did I multiply a plus 1 by to get to this? An a. So let's see what we get. We get an a plus 1, and we get a plus a. Now, can we simplify that numerator?
2a.
Yeah, absolutely. It's going to be a 2a, isn't it? I'm just going to erase it. Is that all right with you? So it's, watch, it's going to be 2a plus 1, isn't it? Instead of writing down that whole entire step again, just for that, I'm going to put 2a plus 1. So it's 2a plus 1. How did I get that? I added the a and the a together, right, to get to 2a and then the plus 1. Now, there's really nothing I can do to simplify this numerator, and there's nothing I can do to simplify this. Now I'm ready to divide. But the division's easy, because division really isn't even division with fractions, is it? Division is the same thing as multiplying by what? What's the word again? The reciprocal. Good. So we're going to, which one do we keep the same? The top one, all right? We keep the top one the same, and then we flip the bottom one, okay? That's what we take the reciprocal. So the top stays the same, just like that. And instead of dividing by this, what do? We multiply by the reciprocal. So multiply, so I just flip these two, right? So what do I have on top? I got a times a plus 1, and on the bottom, I have 2a plus 1. This actually wasn't that hard, to tell you the truth. I don't think it was, do you? So look at this. What can we do now? Remember what we did on the other step? Cancel out. Yeah, cancel out. Because look, what is this a doing to this and to this stuff over here? It's being multiplied by everything, right? I could have put that in parentheses. I could put this into parentheses if I wanted to. That a is being multiplied by everything. So yeah, I can cancel that out if I have an a on the bottom that's being multiplied by everything. Same thing with the a plus 1. This a plus 1 and this a plus 1 cancel out. Isn't that fun? I love doing that. Whopping those things off of there. Okay. What about this? I got a 1 here and a 1 here. Can I cancel those out? No. Why not? Third time today. Because it's being added. Right. You can't cancel that. So nothing else cancels out. So I'm ready to write my answer. It's just a squared plus a plus 1 over 2a plus 1. And that's it. That thing right there doesn't factor. Try it. It doesn't factor. Okay? So you can't do anything else with that. You just leave it just like that. And that's your answer. So, are really complex fractions, are they really that complex? Are they really that difficult? I don't think they are. Okay, I think what do you think the hardest part of this is? It's probably not even doing the division, is it? I think it's going from here to here. I think that's probably the hardest part of this problem, is just finding common denominators, adding the fractions together. The actual division part, I think that was a piece of cake, don't you?
I think it's just remembering to divide.
Yeah, you got to remember to divide, absolutely, but you got a big old bar here, right? So it's pretty obvious, I think, that you have to divide. So make sure that you multiply by the reciprocal. Now, finally, After a week of doing this dumb lesson 515 or whatever it's called, finish up the rest of the problem. So what's it go up to? It's like, what, 16 to 20 or something? Or
Yeah.
is it 20? Okay. So look, it's only 5 problems. They're all like this. Look at the video if I went a little fast, okay? Because a couple of these things, I was kind of going a little bit quick, not too fast. I try to explain everything. But if you don't get it, look at the video and look at your notes, all right? Don't forget your notes, okay? And everybody should be taking notes every single day. This should all be written down in your notes, all right? But if you didn't understand what you were writing or why you wrote it, then you can go back to the video and listen to the explanation. All right, so numbers 16 through 20, that'll be due tomorrow, and we'll be ready to move on to the next lesson.